In this segment, we're going to take a look at the program design. So what we're going to look at is how to start programming. This is the first module or first segment of the module in programming. So up till now, we'll assume that you are working in any type of language and you're just getting started. So we're going to take a look at this particular design program. Now, designing a program, there's a lot to be done before you even start sitting down at the typewriter. In fact, most people, the first thing they do when they think about designing a program, and I've got students that do it, they grab the keyboard, they sit down when I give them a project, and they sit down and they start typing. Well, that's not what you really need to do. Before you even start putting the first statement on the program, what you're going to need to do is sit down and actually design. Figure out where are you going to go? What is the goal for this? That goal then will determine exactly what you're going to use in the programming, what type of steps are you going to do. So some people have, over the years, have developed a program development cycle for us. And it's basically very simple 5 steps. There are several development cycles out there. Some of them have 6, 7 steps. I like this one. It's very simple. Simple 5 steps that puts everything together in a small package. The first thing you're going to do is you're going to design the program. Now, we'll talk about designing because it's not as simple as it sounds, just those 3 words. But after we finish the design, then we're going to sit down and we're going to figure out, okay, let's sit down and start writing the code. After that, we're going to correct the syntax errors. Now, one of the things that my students get all upset about, well, you know, I can't seem to do this the first time, is, you know, and they get real frustrated with it. Let me tell you right up front, you're going to fail. You're going to make mistakes, and there is no way around that. It's part of being a human being. I don't care whether you're sitting down to write a term paper or whether you're sitting down to write code. You're going to make mistakes in grammar, punctuation, spelling. All those are syntax errors. And so after you finish writing the code, you're going to find, as you write it and run a little bit of it, write it, run a little bit of it, or you're going to sit down and review what you've typed, you're going to find that you've made syntax errors. And you go back and you correct the place where the words are misspelled, the punctuation's not in the right place. Some programs, the design environment that you write in will give you clues of where the syntax errors are. Once we've done all that, we've got the program where we think we want it, then we're going to sit down and we're going to test this program. Now, in testing the program, we're going to run through it, and what you're going to find is the program ran just beautiful. It's one of those yes type moments. And then you start looking at it and realize it's not satisfying what the customer wants. It's not doing exactly what you want. You've done a program, beautiful math program, and you find that the answer isn't even correct. It didn't even close. Well, these are called logical errors. So logic errors are those type of errors that are a mistake in the programming, but they don't stop the program from running. However, they give you incorrect results. From there, now that we've got the design cycle in mind, let's talk about designing the program. Now, one of the things that programmers like to do is they do like to eat. We do like to be able to have a living. So consequently, a lot of your programming, hopefully, is going to be something you're getting paid for. Now, in any type of commercial endeavor, you're going to find that the client is always right. They're the ones that they know what they want, or they think they know what they want. So what you're going to do at first, before you do anything else, you're going to sit down with that customer. You might spend several weeks working with the customer to find out exactly what the customer wants you to do. What is the goal that they're trying to achieve? What do they think that the computer can do for them? And so you're going to ask a lot of questions about what the customer wants, and it's a give and take between what programming can do and what they want you to do. Once you get this, you're going to create one or more software requirements, which is going to then be agreed to between you and the customer, that this is what you're going to design to. Once you've got that, it's not going to be the last time you talk to the customer. I can promise that. It's going to be back and forth. Okay. Once you've got the design idea down, now you know what the customer wants you to do. Now let's take a look at how to do this. We've got what the customer wants. Now we're going to sit down and we're going to determine what steps need to be taken. We're going to break this down into requirements, into a series of steps, like that coffee cup that I talked about. What steps are we going to do to make that cup of coffee? So you're going to break that task down into a series of steps. You're going to create an algorithm. Basically, it'll be a series, it might be just in straight text, of what are the logical steps that must be taken. That coffee cup, raise the hand, open the door, grab the cup, pull the cup out of the cabinet, put the coffee cup down on the counter. So you're going to create this statements, and they're going to be logical, and they're going to be set against what the task are. The other part about this too is you might even break the whole thing down into several tasks. For instance, that grocery store, the task of inventory versus the task of keeping track of the money. Okay. So we're going to look at getting that all written out so you have it firmly in your mind. Next thing you're going to do is you're going to use one of two different programs or one of two different ideas to put this together. Now, one of them is Pseudocode. The other one we're going to talk about is a series of symbols. So Pseudocode literally means fake code. It's going to be informal. You're going to write out the steps as if you were writing code, but you're not going to worry about syntax. You're not going to worry about the rules or anything. You're just going to write out the steps. It's not meant to be compiled. It's not a program that's going to run, but it's used to create the model that you are going to write against. And then we're going to take this pseudocode and literally translate it into the actual code itself. The other idea we have is doing flowcharts. Now, flowchart is a diagram that graphically depicts all those steps that you wrote in the pseudocode or in the algorithm. You're going to take that algorithm and you're going to just put it into a set of symbols. Now, we use these 4 basic symbols that's on the screen to provide that series of a visual depiction of what you're going to write. And then you can turn around and write your code directly against that particular flowchart. So as you can see, ovals, parallelograms, rectangles, they process the symbols, and then all the symbols are connected by arrows. And that's probably the most important part of this, is to make sure that the symbols from the start to the end are connected. The flowchart looks like this when you're done. Let's take an example of this where we can go start a program, we get the speed of the train, we get the hours en route, and calculate the distance traveled and to display the distance. Now, if we actually did this backwards from the flowchart, it would look like this. Here's the client's question that they've asked us. And they've asked us to develop this program to automatically compute the distance traveled by a train in a certain number of hours. So now we've written the algorithm, and now we take it and write it in a flowchart. And here we can see we need to get the speed of the train here. We need to get the hours en route. And notice the flowchart, this one's very linear, just straightforward from start to end. Once we finish this, then we're going to be able to write all the code directly from it. Okay, so we've gone over what designing the program, deciding what form you wanted to design in, whether it be the pseudocode, flowchart, or you might use a combination of both of these methods. Then you're going to write the code, correct the syntax errors, test the code, and then you notice correct the logical errors. And if you'll notice, I've put an arrow there because it should be there. You're not going to run this program the first time and get it to work, even a small program. I've been doing it for a number of years now, and I still have to rewrite it at least 3 or 4 times just for a small program of 100 lines or so. So the big thing is don't get frustrated. Just accept the fact that you've got to work through the errors. Consider it a puzzle that you've got to solve. So remember, designing is not just sitting down in front of a keyboard and starting to type. If you start to find yourself doing that, it should be automatic to stop and go back and let's take a look at what the program is meant to do. Thank you.